Hi everyone, in this video I want to introduce what a capacitor can do with regard to an electrical circuit, and by making some simple observations of what this little black cylinder of a capacitor does with this circuit of batteries and light bulbs, we can actually understand what's happening inside of that device to talk about how that device is moving and manipulating charge. Let's start by talking about the batteries. These batteries here, 2D batteries, this is similar to what we may have used in lab this week or last week. We have these batteries here. This yellow wire just simply connects these two batteries so that I have a larger voltage, a larger potential difference, like what you do when in a flashlight you stack the batteries end to end, or in your remote you always have to put them in opposite like this because there's just a wire that connects those two, so I have 3 volts instead of 5 volts. I have my voltmeter here. We can measure the voltage across our batteries. So here's the first battery. We see that it has a voltage of roughly 1.5 volts. The other battery has a voltage of 1.5 volts, which means that my total voltage end to end is going to be 3 volts. So I'm just measuring the total voltage of my batteries. I have roughly 3 volts potential difference. I have these red wires here that allow me, oh, my wires got crossed, there we go. This red wire is connected to this simple flashlight bulb. When I connect it, I now see that my light bulb lights up. It glows very brightly. Let's move that just like that. So what's happening here is the charge separation from the batteries, the chemical processes in the batteries allow charge to maintain its separation. I've got plus charge, minus charge. That charge wants to get together, but it can't go backwards through the battery, so it instead all the electrons leave the negative end. Really, there is a pushing of all the electrons already within the wire that pushes electrons that are in the filament through the filament. Collisions occur in the filament that cause the bulb to light up. Now the pushing and the energy that I get comes from the stored electrical energy in the battery, converting the electrons to kinetic energy. They're moving through the wires, colliding with atoms in the filament, providing thermal energy and light energy. Now let's see what happens when we introduce the capacitor into this circuit. I'm going to move this just slightly. And I am going to, we'll show a close-up, right? This is a capacitor. It's a little black cylinder. Inside of this are 2 parallel conducting plates. They're actually 2 little bits of foil that are wrapped around each other with a gap in between. We'll talk more about the actual construction of this in class on Friday. And I have it connected to nothing, so I'm going to measure the voltage across this capacitor, and that voltage will tell me that, and I'm just making sure that we start out at 0, will tell me how much charge is separated on those plates. So when I've connected it now, there is no charge on those plates. I have a very small voltage due to there not being any charge. Now I'm going to insert that capacitor into our circuit. So now instead of just going through the bulb, the electrons can go through the bulb and then into this wire. This green wire is what's connected to the capacitor. This red and black wire are just allowing me to measure my voltage. So as I connect my circuit, we see something interesting is happening to my voltage. My voltage is getting bigger and bigger and bigger and bigger. That means across these 2 plates within the capacitor, there is more and more and more and more charge separated. That increased separation of charge comes from the battery pushing charge onto those conducting plates. I take electrons, I'm pushing those electrons through the circuit due to the potential difference and the potential energy supplied by the batteries. But there's a gap between those plates. Those 2 plates cannot allow charge to go from plate to plate within the capacitor. So as I shove electrons onto one plate over here, I can't get them to keep moving across to go back to the battery, even though they want to. That means that the ability for current to be, for charge movement to be supported in the circuit is lost. I actually have more negative charge here than I'm trying to push charges against, and they reduce the effectiveness of our ability to push those charges onto that negative plate is reduced by the buildup of those negative charges. The whole time I've been talking, you may have noticed that this light bulb started bright and went out. That's because the movement of charge diminished. The amount of charge per second got less and less and less. because my ability to push charge from the batteries maintained the same voltage. We see that our voltage, it's still increasing because there's still charge flow even though I can't see it through the bulb's not on. But the voltage that we're working against is increasing as I stack those charges, and I see that there's soon a point where I had roughly 3 volts. Now I'm working against roughly 3 volts, and I can't really push that charge anymore. We'll understand this more in our next chapter when we talk about current and Kirchhoff's rules of voltage and current. But right now we see that my voltage is increasing. Now I'm going to stop this for a moment. So I'm going to disconnect my circuit. There's still a little bit of charge, but we're almost at 3. And now we see with it disconnected, this value might go down slightly. But that's really just because I'm connected to my voltmeter. Let's make it go down faster. I'm leaking some of that charge off. Let's watch what happens when I connect this light bulb. Now I'm connecting the light bulb just to the capacitor. So that was storing electrical potential energy that now I can use up instead of the batteries. The batteries aren't connected at all. Here's the batteries. Batteries aren't connected at all. That light is not coming from the batteries. It's coming from charge that must have been separated on those 2 plates. The charge can't go across the capacitor, so now the charge is actually going in the other direction through this circuit. Now charge is flowing in the opposite direction than it was initially because I am recombining that charge that was separated by the capacitor plate. So we can continue to watch this. Notice that this light bulb is getting dimmer and dimmer because the voltage of my capacitor is getting smaller and smaller. It's like having a smaller battery attached to my bulb as time goes on. Now it's just a 1-volt battery. It started out as almost a 3-volt battery, and that means, of course, that my light bulb is no longer burning so brightly. So just a quick little demonstration on what is happening with the capacitor. We are making macroscopic measurements of voltage and observances of current in terms of the bulb being on and off, and using that to understand what must be happening microscopically with the charge from the batteries through the wires and separated on the capacitor plates.